Section 13.2 is on angle measures. Now that we've taken our triangle trig and made sense of it, we take the trig and put it on a coordinate plane. So I have an x and y axis now, and we can do angle measures here. Every angle that you measure on the coordinate plane is coming off of this segment here. Not just the x-axis, but the forward-facing portion of the x-axis, not the backwards-facing portion. So if I drew an angle that was 45 degrees, that's this. This right here is a 45-degree angle if it's in standard position. So things that are in standard position are coming off that side of the x-axis. And if I drew an angle here, this would be about 120. And if I keep on going, like suppose I drew this angle here, well, this right here we could think of as being negative 10 degrees. If you're going clockwise, you're going negative. If you're going counterclockwise, you're going positive. I know that seems kind of backwards, but that's how it goes because this is the positive quadrant. Everything's positive there, and everything's negative in this quadrant over here. So this negative 10 degrees, going down negative 10 is the same as going forwards 90, 180, 270, 350 degrees. So a 350 degree angle is actually the same as a negative 10 degree angle. And those are called being coterminal. Coterminal angles are angles that end in the same spot, and we'll talk about that in a second. So all these angle measures just come off the x-axis. So if I said graph something that was 210 degrees, well from here there's 90, there's 180, so I'd go about 30 more, and this right here would be a 210 degree angle. As I mentioned moments ago, coterminal angles are angles that end up on top of each other. So for example, 20 degrees, and then 360 plus 20, 380 degrees are coterminal. And here I can think about this angle here like it's 210, or like it's negative 90, I'm going to have to go another 60, so negative 150. 210 and negative 150 are coterminal. Now there's an infinite number of coterminal angles. I mean, if you think about something that was at 90 degrees, that's going to be coterminal with another 360, which makes it 450. And I can go another 360, which makes it 810. And I can keep on adding 360s as often as I want. So there's an infinite number of coterminal angles, and I also could have gone in the negative direction. 90 is the same as negative 270. So coterminal angles are angles that end up on top of each other. They end up in the same spot. Okay, what's a degree? There's a question that if we were in class I would ask you. If you want to pause and think about what a degree actually is, that might be worth doing. Maybe you've never really considered it. Don't think about temperature. We're not talking temperature. We're talking angles. A degree is technically just 1/360th of a circle. Really, we just take this circle and just break it up into 360 little pieces, and a degree is the distance between one of those. And that's probably too big for a degree. I mean, I don't think I can fit 90 of those into a right angle, but a degree is 1/360th of a circle. Well, why 360? I believe it was the Babylonians that just loved the number 60 because it could be divided by 1, 2, 3, 4, 5, and 6. So they took 60 and made a circle of 6 60s for 360 degrees. And while there's some conveniences to that, because 360 can be divided by so much, what's actually better is to use a new system of angle measurement. So it's called radians. A degree is just one way that we measure an angle. We measure kind of the chunk around a circle that we've traveled. A new way of measuring that is what's called radians. Radians are kind of odd to get used to, but they're incredibly useful and helpful. You will find that radians are much easier to work with than pretty much everything else. So here's a circle. It has a radius of r length. The radius is length r. And if I were to measure the circumference, we know the circumference is 2 pi r. 2 times pi times the radius gives you the circumference. Well, if I were to take this radius right here and think about it as a piece of string, and spread that string out along the circle, how many times do you think it'd go around? And you can pause and think about how many times it actually goes around. And you know, the lengths I just drew, I'm just kind of making up, so we're not going to be super precise with this. But it will actually go around a little over 6 times, and that's where my drawings aren't very good. but the radius is going to go around the circle 6 times. In fact, a little over 6. Think about it, what we're doing is we're taking the circumference and we're dividing it into pieces that are of length radius. So we're really dividing it into r pieces. And c divided by r equals 2 pi, and 2 pi is about 6.28. Well, that's what we call 1 radian. 1 radian is the distance that you travel along the radius. Okay, let me rephrase this. Here's the radius of a circle. If I take that radius and travel that far along the circle, and I measure the angle that that makes, that is called 1 radian. So a radian is a way to measure an angle, just like a degree is a way to measure an angle. I mean, we have all these ways to measure a length. So we can do feet or inches or miles or kilometers or centimeters or whatever. And we have all these ways to measure weight and mass with grams and kilograms and pounds and all those things. And now we have 2 different ways to measure angles. One is degrees that you're used to, the new one is radians. So you'll notice that 1 radian is substantially bigger than 1 degree. And we'll see how much bigger a little bit later on. But it would take 2 pi radians to go around a whole entire circle. So 2 pi radians is the same as having 360 degrees. When you deal with radians, there's pretty much always going to be a pi in them. And that what's kind of is hard to get used to. We don't use decimals with radians. We tend to stick with pi's, but it makes the calculations a lot simpler. So first it's going to convert between radians and degrees. I said that 2 pi radians was 360 degrees. That means that pi radians is just 180 degrees. Now, seeing pi radians and having to live with that might be kind of weird. You can think about this as 3.14159 radians if you want to, because it is some number, but just stick with the simple pi. If you're trying to convert from radians to degrees, take the number of radians that you have and multiply it by 180 over pi. And when you multiply by 180 over pi, that'll get you into degrees. So if I have like 3 pi radians, I would take that and I would multiply 3 pi by 180 over pi. And the nice thing is the pi's cancel, and I'm left with just 540. So 3 pi radians is really 540 degrees. And I'll use a number that doesn't have pi in it, even though we don't do that very often, if I had like 1.5 radians. Well, remember, 6.28 is about a whole circle. 2 pi is about 6.28. So 1.5 is going to be about a quarter of a circle. So I expect this to be around 90 degrees. So I'll do 1.5 times 180 over pi. Well, since this number didn't have a pi in it, I'm just going to do the calculations on my calculator. It doesn't matter here if you're in radians or degrees, because you're not doing sine, cosine, or tangent. You're just doing calculations with numbers, so don't worry about what mode you're in. 1.5 times 180 divided by pi. It's about 85.9 degrees. Like I said, close to about 90 degrees. So you want to start trying to learn to think about circles in radians. Think about the fact that 2 pi radians is a whole circle. So 1 pi radians is half a circle. And pi over 2 radians is going to be a quarter of a circle, or 90 degrees. Now we'll go the other direction, degrees to radians. We'll do some kind of simple numbers first. So we'll do 60 degrees. If I want to find that, I just take this fraction that I had over here and I flip it over. Instead of 180 over pi, it's pi over 180. So I'll do times pi over 180. And I want to reduce this fraction. 60 is really 60 over 1, and the 60 and the 180 can cancel to become 1 and 3. So we would call this pi over 3 radians. Yes, you could find a decimal. It'd be pretty close to 1, a little bit more than 1 radian. But pi over 3 is how you want to think of that. You'll see how nice it gets to use pi and all these things later. So if I have like 72 degrees, well, if I do that times pi over 360, I can reduce 72 over 360 as far as I can. Probably not very far, but we'll see. 72 divided by 360 and make that answer a fraction. And that was a fifth. I should have figured that actually. So it's going to be pi over 5 radians. If you want to write down rads to reduce radians, that's fine. I'll know what you mean. You're just doing a basic chemistry conversion where you're getting units on top and canceling them with units on the bottom. But that's all this is. You're multiplying by 1. because pi radians over 180 degrees is going to equal 1, because you're dividing the same thing, half a circle, by half a circle. So it comes out to 1. So you're multiplying by 1, you're just canceling units. Degrees cancel, you end up with radians. So the question is really, how big is a degree? 1 degree is how many radians, and we can do 1 radian is how many degrees. It's kind of my funny way of writing this. So here, 1 degree is how many radians. I would take 1 degree, multiply it by pi over 360, and I could do, it's a pi over 360 radians. Right now, that doesn't really mean anything to you, so I'll simplify or find that decimal, close to 120 probably. Sorry, not 120, the reciprocal of 120. So anyways, pi divided by 360. 1 degree is 0.0087 radians. Not very big. And 1 radian is how many degrees? Well, I do 1 times pi over 360, or 360 over pi, excuse me. And that's going to come out to around 120. Oh, did I break it? I did. I'm just too fast. Okay, that was nuts. That's also nuts. Okay now? I think so. 360 divided by pi. Okay. 360 divided by pi. 114.5. So 1 radian is 114.5 degrees, so it's really quite big. You'll note that 114.5 is just the reciprocal of the previous answer. They're just reciprocals of each other because we just took these fractions and flipped them over. Okay, here's one way to find, to see how radians are so useful. Trying to find an arc length. Arc length means how long is this curve right here. And if we know what the radius of a circle is, and if we know the angle inside of that circle that we're finding, we can find the arc length s of any distance. It's very, very easy to do with the length of radius if it's in radians. If it's not in radians, it takes a little bit of fraction proportion work. It's really not too bad. But if you have your radius in radians, finding the arc length is just doing the radius times the angle. It's just r times theta. So let's say here that the radius is, I don't know, 9 centimeters. And we'll do, I don't know, pi over 3 radians. And you don't have a great concept yet of how big that really is, but that's okay. I mean, that picture's kind of close, but not super close. If I do 9 times pi over 3, however, and I'll just live with the decimals here because I want an actual length. 9 times pi divided by 3. 9.42. So this arc length here would be 9.42 centimeters. That's how long this actual curve right here is. If we wanted to do that with degrees, so suppose I made another circle and it was in degrees, I would have to find, so let's say this was 70 degrees. I'd have to see what percentage of a circle is that. So that's 70 over 360. And I'm doing that chunk of a circle. Then I would take that chunk of a circle and multiply it times the 9. And really all you're doing is getting yourself into radians. When you do the 70 over 360, you're getting yourself into radians, but you also have to worry about the circumference itself. And so it's just kind of a pain. Don't worry about it. Just live with this formula and do everything in radians. That takes care of that.